Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1458, indicates a problem related to the fuel tank pressure, FTP sensor circuit. This component plays a critical role in monitoring changes in pressure within the fuel tank and can influence the vehicle's emissions control system. Located on the fuel tank, the FTP sensor transmits pressure data to the Powertrain Control Module, PCM, for analysis. A fault in this circuit can lead to performance issues, increased emissions, and potential driving complications. Proper diagnosis requires special tools, such as a vacuum pump gauge, to accurately evaluate component functionality. It's crucial to handle this code with care, as multiple DTCs could appear simultaneously, necessitating a systematic troubleshooting approach. The FTP sensor is designed to measure the pressure inside the fuel tank and communicate this information to the PCM. When the voltage or circuit range is outside the expected parameters, the P1458 code is triggered, indicating a potential malfunction. Located on or near the fuel tank, this sensor is crucial for ensuring that the vehicle operates within environmental regulations. Proper functioning of the FTP sensor prevents excessive emissions and promotes vehicle efficiency. If this sensor fails or provides inaccurate readings, other components may also be affected, such as the EVAP canister vent shut valve. Thus, understanding its role and diagnostic importance is essential for effective repair. Diagnosing DTC P1458 involves considering several possible causes. A faulty FTP sensor is the most common reason for this error code, as it may not provide accurate pressure readings. Additionally, wiring issues such as frayed wires or poor connections can interrupt the signal the sensor sends to the PCM, eliciting code P1458. Other related components, such as the EVAP canister vent shut valve, may also contribute to the issue if they malfunction or become blocked. It's important to note that addressing these potential causes systematically will lead to a more accurate diagnosis and ensure that all contributing factors are considered. Continually checking for additional DTCs during troubleshooting is recommended, as they may provide further context. When the P1458 code is triggered, a driver may notice several noticeable symptoms. The check engine light will illuminate, serving as an alert that the onboard diagnostic system has detected an issue. Additionally, drivers might experience poor fuel efficiency due to improper fuel management caused by the faulty FTP sensor. Other symptoms can include erratic engine behavior or rough idling, leading to noticeable performance issues when driving. It's essential to acknowledge these symptoms as early warning signs that can help prevent further complications down the road. Addressing the P1458 code promptly ensures that driving performance remains optimal and that emissions stay within regulatory limits. The first step in addressing DTC P1458 involves turning the vehicle to the on mode, but not starting the engine. This ensures that critical vehicle systems are powered without engaging the engine itself. Using the Honda Diagnostic System, HDS, you will record necessary snapshot parameters, including the maximum and minimum values of the FTP sensor and the fuel level in the data list. This data is essential for comparison in subsequent diagnostic steps. It's imperative to ensure the fuel level is lower than the recorded snapshot value during this process. Doing so prepares the vehicle for further tests, allowing accurate results without interference from excess fuel pressure that could skew the readings. For the second troubleshooting step, you must select the EVAP test option from the HDS inspection menu. After initiating the test, select EVAP CVS off in the single solenoid configuration while ensuring the engine remains off. This will allow you to take a snapshot of the FTP sensor parameters over a 3-minute period. You'll then assess the recorded maximum and minimum values of the FTP sensor to check whether they are within the specified range of plus minus 0.67 kilopascals, 0.2 inches mercury, 5 millimeters mercury. If the readings are in the acceptable range, it indicates that the FTP sensor may be functioning correctly. Otherwise, further investigation into other components is required. This method effectively narrows down the issue to the FTP sensor's performance. In the third step, focus on evaluating the FTP sensor's performance by checking the FTP sensor fine readings. During this phase, you should assess if the readings vary by at least 0.067 kPa, 0.02 inches, 0.5 millimeters per second within 3 seconds to confirm its functionality. A significant variation indicates that the sensor is responsive and possibly functioning correctly. If the sensor does not exhibit this variability, you may be looking at an intermittent failure, meaning the issue may not be consistent but requires attention. It's advisable to check for any loose connections or corrosion at the FTP sensor, the evap canister vent shut valve, and the powertrain control module, PCM. Additionally, examining the evap vent hose for blockages can uncover hidden faults that affect performance. In the fourth troubleshooting step, you will take steps to confirm the FTP sensor's integrity. Begin by turning the vehicle to the off position, allowing systems to reset. Once the vehicle is off, carefully remove the FTP sensor and reconnect the FTP sensor's 3-pin connector. Powering the vehicle back to the on mode will enable you to check the readings from the FTP sensor fine again. If the readings reflect a variance of 0.067 kilopascal, 0.02 inch waven, 0.5 mmH, or more within 3 seconds, then the sensor itself is deemed functioning correctly. However, if the readings are still not satisfactory, consider that this may indicate an intermittent issue once more, and proceed with checks for wiring connections, or even suggest sensor replacement if necessary. For step 5, start by removing the fuel fill cap and waiting for a minute. This allows for any potential pressure release within the fuel system. Afterward, using the HDS, verify the parameters of the FTP sensor fine against specific threshold conditions. The current values must be accurate relative to conditions of more than 0.67 kilopascal or less than negative 0.67 kilopascal for a proper diagnostic guide. If the readings do match these thresholds, it's essential to proceed to the next steps to isolate the issue further. Should they not match, the next step is to reapply the fuel fill cap and then move on to the next troubleshooting procedure. This method effectively examines the influence of the fuel system on the FTP sensor readings. Step 6 requires carefully reconnecting the FTP sensor after ensuring the vehicle is in the off mode. Reconnecting ensures that a fresh assessment can be made while monitoring the FTP sensor fine values. Observe the parameters once again with the HDS and verify they align correctly with signal thresholds. Specifically, the readings should exceed 0.67 kilopounds and fall below negative 0.67 kilopounds. If they adhere to these thresholds, proceed to the next step for further diagnostics. If discrepancies arise, it indicates that there might be a blockage within the FTP sensor's vent hose, affecting readings. A blockage should be cleared, or, if persistent, the hose should be replaced to ensure that pressure is accurately conveyed to the sensor. In the 7th step, power the vehicle down to the off mode and disconnect the FTP sensor 3P connector. This reset enables you to conduct a visual inspection for blockages or damages at the FTP sensor ports, both on the evap canister side and vent side. If any blockage or damage is discovered, that can directly impede the sensor's functionality and cause improper pressure readings. Address these issues by either clearing any blockages or considering replacing the FTP sensor if necessary. Performing this visual check is crucial, as sometimes issues are not detectable solely through electronic diagnostics. Physical examinations can reveal unseen structural faults affecting the function. The final step involves a thorough check of the evap canister vent shut valve to determine its operational status. Begin by turning the vehicle to off mode. Then disconnect the vent hose from the valve port. Attach a vacuum pump/gauge that operates up to 30 inches of air to the valve port, and switch the vehicle to on mode while applying vacuum. This is crucial, as you need to monitor whether the FTP sensor, fine, maintains a reading above 1.3 kilopascals, 0.4 inches. 10 millimeters mHg of vacuum during testing. If the valve holds the vacuum effectively, it indicates that the valve itself is functioning properly. Conversely, if it does not, then replacing the evap canister vent shut valve is recommended. Ensuring that the valve operates without leaks is vital for maintaining the integrity and performance of the vehicle's evap system. After completing troubleshooting, it's essential to perform a final verification of repairs made concerning DTC P1458. Confirming that no DTCs are present at the end of this process is fundamental, as it reflects the successful resolution of the issue. Conducting a test drive allows for real-world assessment of the vehicle's performance, ensuring that the initial symptoms no longer surface. Monitor the FTP sensor function to ensure it operates within the specified parameters. By rechecking these aspects, you ensure that no underlying issues remain unaddressed, and the repair integrity is upheld. This step solidifies the reliability of fixes applied and guarantees positive user experience moving forward. To mitigate the risk of encountering DTC P1458 in the future, implementing preventive maintenance strategies is paramount. Regular inspections of the fuel system, including an assessment of the FTP sensor and associated wiring, will help identify potential issues before they evolve into significant problems. It's also prudent to conduct periodic tests of the evap system, which can uncover issues related to pressure regulation that might not be apparent during everyday driving. Keeping the fuel system clean and ensuring connections are secured can extend the lifespan of your components and enhance vehicle performance. This proactive approach minimizes the likelihood of future diagnostic trouble codes and keeps the emissions system functioning optimally. In conclusion, understanding the implications of DTC P1458 allows for informed and effective troubleshooting of the FTP sensor circuit and related components. The FTP sensor's role in managing fuel tank pressure is vital not only to vehicle performance, but also to environmental compliance. Following a systematic troubleshooting approach allows for accurate diagnosis and resolution of the underlying issues contributing to this code. Additionally, engaging in preventive maintenance practices minimizes future occurrences of similar trouble codes and promotes the longevity of vehicular components. Emphasizing the need for regular checks ensures both driver safety and adherence to emission standards moving forward. Please like and subscribe to the channel. See you next time!